The term rigor is widely used by educators to describe instruction, schoolwork, learning experiences, and educational expectations that are academically, intellectually, and personally challenging. Rigorous learning experiences, for example, help students understand knowledge and concepts that are complex, ambiguous, or contentious, and they help students acquire skills that can be applied in a variety of educational, career, and civic contexts throughout their lives. To paraphrase Ronald Williamson and Barbara Blackburn on their Recognizing Rigor in Classrooms 4 Tools for School Leaders, rigor is about expectations. Rigor is creating an environment in which each student is expected to learn at high levels. Also, with high expectations, it is important to have instructional supports to simultaneously provide ongoing scaffolding to support students' learning as they reach higher levels. Another component of addressing rigor is exposure. Students need opportunities to demonstrate learning at high levels. For us to look at cognitive demands of these items, we need to be mindful of the rigor distribution. It is important to look at instructional practices that expect students to learn at very high levels, and that also give students the support to achieve. And in assessment, not all items should fall on a very demanding spectrum of rigor. So what is rigor? Here are some general reasons and considerations of rigor in item development. For the development of assessment items and tasks, universal design aims to create items and tasks that accurately measure the targeted knowledge, skills, and abilities for all students. Valid assessments of student knowledge, skills, and abilities requires a two-way communication between an assessment item and a student that involves 3 critical steps. The first, focus on presenting information to a student in order to activate or stimulate the knowledge, skill, or ability that is the target of the assessment. Second, student is provided an opportunity to interact with the content that is presented by an item as he or she applies the targeted knowledge, skill, or ability. Third, the student provides evidence about their knowledge, skill, or ability through the response to an assessment item or task. It is through this 3-step process that an assessment item or task attempts to access the targeted knowledge, skills, or abilities that operate within a student. For the cognitive rigor to be attended to, item writers must consider the depth and breadth of knowledge communicated by these targeted expectations. An aligned assessment must include items and tasks requiring the highest level of cognitive complexity prescribed by the assessment claims and targets. The Smarter Balanced Assessment has adopted the Cognitive Rigor Matrix for the assessment program. This matrix draws from 2 widely accepted measures to describe cognitive rigor: Bloom's Revised Taxonomy of Educational Objectives and Webb's Depth of Knowledge Levels. The Cognitive Rigor Matrix has been developed to integrate these 2 models as a strategy for analyzing instruction, for influencing teacher lesson planning, and for designing assessment items and tasks. This matrix was developed by Karen Hess. The Common Core state standards require high-level cognitive demand, such as requiring students to demonstrate deeper conceptual understanding through the application of content knowledge and skills to new situations and sustained tasks. We will preface the cognitive rigor matrix used by the Smarter Balanced Assessment by providing a brief history of the revised Bloom's taxonomy and the depth of knowledge. Although related, their ties to complexity of thought, these methods differ in scope and application. Bloom's taxonomy characterizes the cognitive skills required of the brain to perform a task, describing the type of thinking processes necessary to answer a question. Depth of knowledge relates more closely to the depth of content understanding and scope of learning activity, which manifests in the skills required to complete the task from inception to conclusion. The cognitive rigor matrix allows educators to examine the depth of understanding required from different tasks that at first glance seem comparable. The cognitive rigor matrix allows educators to uniquely characterize and examine selected assignments and learning activities that appear in curriculum and instruction. The cognitive rigor encompasses the complexity of content, the cognitive engagement with that content, and the scope of the planned learning activities. The cognitive rigor matrix has significant potential to enhance instructional and assessment practices at the classroom level. Ensuring that the curriculum is aligned to rigorous state content standards is in itself insufficient for preparing students for the challenges of the 21st century. Current research on the factors influencing student outcomes and contributing to academic richness supports the concept that learning is optimized when students are involved in activities that require complex thinking and the application of knowledge. Students learn skills and acquire knowledge more readily than they understand concepts more deeply, recognize their relevance, and can transfer that learning to a new or more complex situation. Different states, schools, teachers use different models to describe cognitive rigor. In short, what is the difference between Bloom's taxonomy and Norman Webb's depth of knowledge? For Bloom, it is what type of thinking, or the verbs that are needed to complete the task. In Webb's depth of knowledge, how deeply do you need to understand the content to successfully interact with it? Here is a look at Bloom's taxonomy from 1956 versus the revised Bloom's process dimensions of 2001. In 1956, Benjamin Bloom developed a taxonomy of the importance to learning. Bloom's committee identified 3 domains of educational activities: cognitive, affective, and the psychomotor. Within the cognitive domain, which is tied directly to the mental skills, Bloom identified the hierarchy of 6 levels that increased in complexity and abstraction from the simple recall of facts and knowledge to the highest order of thinking, such as evaluation. The revised taxonomy table employs 2 dimensions: cognitive processes and the knowledge. The cognitive processes resemble those found in the original taxonomy, but placement on the taxonomy continuum has changed slightly. For instance, the evaluation no longer resides at the highest level, and descriptions have been expanded and better differentiated for analyzing educational objectives. The revised descriptors consider both the processes, the verbs, and the knowledge used to articulate the educational objectives. This restructuring of the original taxonomy recognizes the importance of interaction between what content is taught, characterized by factual, conceptual, and procedural, and the metacognitive knowledge. Bloom's taxonomy provides a way to organize thinking skills into 6 levels, from the most basic to the more complex levels of thinking. These 6 levels provide us with a way to express qualitatively the different kinds of thinking. Let's look at remembering. Can the student recall or remember the information? Let's look at understanding. Can the student explain ideas or concepts? Apply. Can the student use the information in a new way? Analyze. Can the student distinguish between the different parts? Evaluating. Can the student justify a decision? Creating. Can the student create a new product or point of view? Here's Norman Webb's depth of knowledge levels. Depth of knowledge. How deeply do you have to know the content to be successful? Norman Webb's depth of knowledge forced states to rethink the meaning of test alignment to include both the content assessed in a test item and the intended cognitive demand, or the depth to which we expect students to demonstrate understanding of that content. Webb describes his depth of knowledge levels as normative rather than a taxonomy, meaning that the depth of knowledge levels describe 4 different and deeper ways a student might interact with the content. Unlike Bloom's taxonomy, the depth of knowledge levels do not necessarily correlate to the difficulty. These depth of knowledge levels help states and districts utilize the concept of the depth of knowledge to designate the depth and complexity of state standards in order to align the state's large-scale assessments or to revise existing standards to achieve higher cognitive levels for instruction. Consequently, instruction should call for a greater range of cognitive demand. The Common Core State Standards expect students to perform higher on cognitively demanding tasks, but how do you know that the tasks of the students meet these rigorous standards? Depth of knowledge is one way to measure these cognitive demands of the tasks. By using the 4 levels that build in complexity, cognitive rigor looks at the depth of knowledge as well as the type of thinking required for students to interact with and respond to content. Depth of knowledge 1. Students need to elicit and recall information or reproduce information. Level 2. Students should focus on skills, concepts, and basic reasoning. Level 3. Expect strategic thinking and complex reasoning. Level 4. Require extended thinking. Here's one way many districts look at depth of knowledge. The level of the depth of knowledge is determined by the task, defined by the complex thinking and reasoning skills. It is not by the grade level or the ability of the student. Therefore, the depth of knowledge of the task does not change with the grade or the ability of the student. Verbs alone do not determine the depth of knowledge's level of an assessment task. The depth of knowledge focus on how deeply the students need to know the content for a given response. This presentation that is commonly used with schools and school districts is not sanctioned or authorized by Norman Webb. Depth of knowledge is not just about a verb. So to reiterate, depth of knowledge is not about difficulty. It is about complexity. It is not about the verbs. Verbs are not always used appropriately. It is not about the student or level of difficulty for the student. It requires looking at the assessment item, not student work, in order to determine the level. Depth of knowledge is about what follows the verb. What comes after the verb is more important than the verb itself. It is about the complexity of mental processing that must occur to answer a question. In assessment, you should have a range of depth of knowledge levels. You need to have a variety of these levels in order to provide a foundation for students. Let's tease through an example of these claims and targets for items instead of working backwards with an item to showcase the rigor points. So here we have a English Language Arts literacy claim and supporting evidence about this claim. Let's focus on grade 4, where there are 7 targets on this claim. Target 1, key details. Given an inference or conclusion, use explicit details and implicit information from the text to support the inference or the conclusion provided. Here our target would be a depth of knowledge 1 or 2. Shown here is a literary passage. We will use this as reference for the tasks that are presented in this slide. On the left-hand side of the item-specific table, Claim 1 states, students can read closely and analytically to comprehend a range of increasingly complex literary and informational text. The target 5 states, analysis within or across text, interpret, specify, or compare how information is presented across text, first-person or third-person point of view, visual oral formats, topics, themes, patterns of events. In secondary targets, key details, use explicit details and implicit information from the text to support answers or basic inferences. For this table, we're looking at depth of knowledge targets of 3 and 4. The evidence required. When reading literary text, students should cite evidence, and they should make comparisons of how information is related to the theme or topic. The allowable item and types for this would be construct a response. On the right-hand image, we can see a smarter balanced sample task. This shows us how the item specification table was put into use, but how this item or task contributes to the sufficient evidence for this claim. When students read and interpret excerpts from 2 different literary texts, they will compare how patterns of events in the text are similar. Rigor is not mutually exclusive. It is how deeply must the student engage in the content, as well as what type of thinking is needed for the student to complete the task. NAEP refers to student performance on items by scoring multiple choice or constructed response questions as either right or wrong, whereas 60% or more of students have answered this item correctly. Medium items are where 40 to 59% of students have answered this item correctly. Hard items are where fewer than 40% of students have answered this item correctly. When we talk about rigor, we are interested in knowing the mental processes and the actions that students take in demonstrating their understanding. Now we will look at how we can raise the bar when we're looking specifically at content area rigor. For more specific on the depth of knowledge levels, please see the handout. Now let's look at each of the descriptions that fall under the depth of knowledge definitions. Here we can see the depth of knowledge 1 for recall, and its definition followed by descriptive terms, or statements. The same is shown for the depth of knowledge 2, skills and concepts. For the depth of knowledge 3, we can see the strategic thinking and reasoning definition followed by more descriptive statements. For the depth of knowledge 4, extended thinking, again we have our definition followed by descriptive statements. According to Norman Webb's Depth of Knowledge for 4 Content Areas published in 2002, interpreting and inciting the depth of knowledge levels to objectives both within standards and assessment items is an essential requirement for the alignment analysis. 4 levels of the depth of knowledge are used for this analysis. Because the highest, the 4th depth of knowledge level, is rare or even absent in most standardized assessments, reviewers usually will be making distinctions between depth of knowledge levels 1, 2, and 3. For the depth of knowledge 1, recall, this includes the recall of information such as fact, definition, term, or simple procedure, as well as performing a simple algorithm or applying a formula. That is, in mathematics, a one-step, well-defined, and straight algorithmic procedure should be included at the lowest level. Other keywords that signify a level 1 include identify, recall, recognize, use, and measure. Verbs such as describe and explain could be classified at different levels depending on how it is described and explained. A depth of knowledge 2 includes the engagement of some mental processing beyond a habitual response. A level 2 assessment item requires students to make some decisions as to how to approach the problem or activity. Whereas Level 1 requires students to demonstrate a rote response, perform a well-known algorithm, follow a set procedure like a recipe, or perform a clearly defined series of steps. Keywords that generally distinguish Level 2 include classify, organize, estimate, make observations, and collect and display data and compare data. These actions imply more than one step. For example, to compare data requires first identifying characteristics of the objects or phenomena and then grouping or ordering the objects. Some action verbs, such as explain, describe, or interpret, could be classified at different levels, depending on the object of the action. For example, if an item required students to explain how light affects mass by indicating there is a relationship between light and heat, this is considered a Level 2. Interpreting information from a simple graph requiring reading information from the graph is also a Level 2. Interpreting information from a complex graph that requires some decisions on what features of the graph need to be considered and how the information from the graph can be aggregated is a Level 3. Caution is warranted in interpreting Level 2 as only skills because some reviewers will interpret skills very narrowly as primarily numerical skills, and such interpretation excludes from this level other skills such as visualization, skills, and probability skills, which may be more complex simply because they are less common. Other Level 2 activities include explaining the purpose and use of experimental procedures, carrying out experimental procedures, making observations and collecting data, classifying, organizing, and comparing data, and organizing and displaying data in tables, graphs, and charts. A Depth of Knowledge 3, the strategic thinking, requires reasoning, planning, using evidence, and higher level of thinking than the previous two levels. In most instances, requiring students to explain their thinking is a Level 3. Activities that require students to make conjectures are also at this level. The cognitive demands at Level 3 are complex and abstract. The complexity does not result from the fact that there are multiple answers, a possibility for both levels 1 and 2, because the task requires more demanding reasoning. An activity, however, that is more than one possible answer and requires students to justify the response they give would most likely be a Level 3. Other Level 3 activities include drawing conclusions from observations, citing evidence, and developing a logical argument for concepts, explaining phenomena in terms of concepts, and using concepts to solve problems. Depth of Knowledge 4, Extended Thinking, requires complex reasoning, planning, developing, and thinking, most likely over an extended period of time. The extended period of time is not a distinguishing factor if the required work is only repetitive and does not require applying significant conceptual understanding and higher order thinking. For example, if a student has to take the water temperature from the river each day for a month and then construct a graph, this would be classified as a Level 2. However, if the student is to conduct a river study that requires taking into consideration a number of variables, this would be a Level 4. At Level 4, the cognitive demands of the task should be high, and the work should be very complex. Students should be required to make several connections related to ideas within the content area or among content areas, and have to select one approach among many alternatives on how the situation should be solved, in order to be at the highest level. Level 4 activities include designing and conducting experiments, making connections. Level 4 activities include designing and conducting experiments, making connections between a finding and related concepts and phenomena, combining and synthesizing ideas into new concepts, and critiquing experimental designs. Here's Karen Hex's Cognitive Rigor Matrix. You can see revise Bloom's taxonomy and how it is correlated to the Webb's depth of knowledge. At an intersection of understand and Webb's depth of knowledge 2, we can use descriptive statements such as summarize results or concepts in order to see if our item fits this area. Now that we know what research and components make up the cognitive rigor, how does this rigor fit an item in our review? For NAEP, the complexity has been given for any items that are 2005 to present. A low complexity means the item expects students to recall or recognize concepts or procedures specified in the framework. Moderate complexity requires more flexibility of thinking and choice among alternatives than those found in low complexity. The student is expected to decide what to do and how to do it, bringing together concepts and processes from various domains. For high complexity items, there are heavy demands on the student. They are expected to use reasoning, planning, analysis, judgment, and creative thought. Students may be expected to justify mathematical statements or construct a mathematical argument. Items might require students to generalize from specific examples. Items at this level take more time than those at other levels due to the demands of the task, but not due to the number of parts or steps. Here is a multiple choice item. For this item, it has been rated a depth of knowledge at a level 1 in Bloom's taxonomy of remember. Students are required to recognize what the shaded region compared to the whole region signifies. This question requires you to show your work and explain your reasoning. In this item, it was rated for grade 8 with a depth of knowledge of 3. In a Bloom's taxonomy of analyze, a student is required to do what has become a standard assessment activity. The extensive wording of the problem can be distracting and creates a problem with the source of challenge. However, the problem that is stated does require the student to do some interpretation to understand what is being asked and to give an argument. The depth of knowledge for this activity would be a 3 due to the source of the challenge. Now we will look at applying all of the things we have learned in the previous presentations into making our own alignment judgments.